so in 7.3, we are going to discuss using similarity and congruence in triangles. So what we had before earlier in this quarter was the idea of the midsegment. And so that talked about the length of the midsegment was half the length of the base. And that's still true. But what happens is instead of talking about those two specific side lengths, we can talk about the ratio of the left and the right side with respect to each other, okay? And so that is called the Triangle Proportionality Theorem. So it says if you have one line that's parallel to one side of the triangle, and it doesn't have to be the midsegment per se, just so you know, and it intersects the other two sides, then that line divides these two sides proportionally. And so we have different ratios that we can set up because they are proportional, which are the ratios. So one of them could be if we have DA and we compare that to the ratio of B to D. So I'll put this like top and bottom. And then so that's going to be in the same ratio as E to C divided by B to E, okay? Or, because remember you do have some options, you can think of it as BD, which is, I call it the top, divided by DA, and that's also proportional to BE divided by EC. Now, another one, and it's not mentioned here because there are lots of them, is I think of what if we did BD, the top, BD, to the whole, BA. That's also going to be proportional to the right top, BE, divided by its whole, BC. And so there's lots of different relationships that you can use based on this idea, all right? And so all we need to know is that the line in the middle needs to be parallel. All right, so some real world uses of triangle proportionality. Well, in the professional world, we can think of multiple routes, okay? And so we can find these distances, setting up proportions, and engineers really do use this strategy. It's a lot used in construction for roofs, distance of objects, bridges, construction on plazas and shopping centers. But in your house, now, you might do this through trial and error, but if you need to know the length of something and you don't have the tools to figure it out and you want to rearrange your rug so it's hidden under your sectional, you could figure out the dimensions and use that triangle proportionality theorem. Okay. All right, so we are going to just take all the application out of it though and find some lengths. So on the first example, it says find the value of x. So that's what we notice. And remember, these two symbols mean parallel. And so we can kind of think, well, how would this work? You have some options. I can do the top portion, SP, divided by the bottom portion. And that's going to equal the other side in the ratio of the top portion divided by its bottom portion. Okay, and that's one option. Now, you might be able to solve this by hand, but I always like to show a setup just in case it's not just obvious mathematically. So because we have a proportion, 6 times x equals 2 times 9, divide by 6, and so x equals 3. And you might have been able to see like, oh, that's 3 times as large, and that works as well, okay? But sometimes it's not always going to be that obvious. All right, let's look at our second example. So here's my parallel lines. So I think of 14 as my whole, so I'll put whole over the bottom. So the whole thing on this is 14. The bottom portion is 4, and that has to be in the same ratio as the whole thing over here. So I'm going to make that 15 plus x all over its bottom portion. Now, this is just one way to set it up, okay? And so remember, we would have to distribute the 4, multiply. Otherwise, since I know that's 14, I can find this length specifically, all right? And so this might be even easier. So this is one option, or I could set up the top over the bottom equals the top over the bottom, okay? But I'm going to go ahead and solve both just to show you. So we would take 14 times x, 4 times 15, 4 times x. So subtract 4x. So 10x equals 60. Divide by 10, and x equals 6. Over here, we get 10 times x, 4 times 15, divide by 10, and so either way we get x equals 6. Very different proportions, but they both work. All right, so let's look at the third example. Same idea, I can find these lengths or we can just use them. So I'm going to do top and whole. So I'll put equals. So the top portion is 20 and the whole portion is 36. The top portion is 5x and the whole portion is 45. And so because these are equal, we can cross multiply. All right, so 36 times 5 is 180. 20 times 45 is 900. So because those are being multiplied, we'll divide by 180. So x equals 5. All right, on the bottom, we're going to have a couple more parallel lines. So all that does is split it up into more regions that have the same ratio. Okay, so I can think of, we still have a triangle region with all these parallel lines, so I can kind of think of it as the middle region over, let's call it the bottom. So middle over bottom. So the middle is 15 over its bottom is 6, and the other side's middle region over its bottom is x, we'll say. Okay, and so depending on what the shape is, what we're looking for, is not always just top and bottom. So 15 times x, 6 times 25. So divide by 15. And so x equals 10. All right, on this one, remember we still have those options. I can do top and bottom, even though it's kind of the middle. And since this one is numerical, I actually would be able to fill that out. So if that portion is 4, then that means this is 6. Okay, and so I would go ahead and use that. So we get 2x minus 10 and 9. And then this side is 4 over 6. So we're going to go ahead and multiply. So 9 times 4, I'll write it out. And this side, we really have 6 times both of these. Okay. So we get 36, and then we want to distribute. 6 times 2x, 6 times 10. So this is why I look for work, because sometimes you might have the incorrect equation, sometimes you might have an algebraic error, but we'll go ahead and add 60. So 96, 12x. So then those are multiplied, so we'll divide by 12. So 96 divided by 12 is 8. Okay. So if I wanted to find a specific length, we could just substitute x back in for what they want. So go ahead and move on to section 7.4 and then try your quiz questions and let me know if you need help.